Here we are going to learn how to use an oscilloscope in Proteus. So to do that, we can go to the generator mode and then select a sine wave, a sine generator, and then place that generator in the schematic capture, and we can change its attributes. Amplitude as 20 volt and frequency as 50 Hz just for the simulation purpose, and then go to the instrument mode and select the oscilloscope and place it here. And now what we are going to observe from the oscilloscope is a sinusoidal signal which is having 20 volt amplitude, the peak value, and 50 Hz frequency. Okay, now we will connect the sine source to the channel A of the oscilloscope. So this oscilloscope is having 4 channels. We will use this channel A, and now we can simulate the model. Once you simulate, in the display you will observe all the 4 channels are available. First thing you need to do is turn off other channels. So the sinusoidal signal is at the channel A. We will turn off channel C, channel B, channel D, and channel A. To make it center, what you can do is change the position of the channel A. Let's make it somewhere here. Okay, so since we are observing an AC signal, you can select that the position to AC. If you are observing a DC signal, you can change that position to DC, or otherwise off. And then this is the trigger section, and this is the channel A subsection, C subsection, and channel B subsection, and channel D subsection, the interface to changing the X and Y axis variables. And here this is the horizontal section where you can change the time, basically the x-axis divisions, and basically it is the time parameter you change here. And if you need to measure the amplitude of this signal, so let's make it center in this signal. So this section shows the voltage per single vertical division. So this 5 means, let's say starting from here, for a single vertical division that voltage value is 5 volt. So for this point 10 volt, for this point 15 volt, for this point it is 20 volt. So our signal is correct because it has 20 volt amplitude. Even into the bottom side you have minus 5 volt, minus 10, minus 15, minus 20. Okay, so that shows it. And if you change it, a single vertical division shows a value of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that is how it works. Even you can change it in millivolt scale as well. So we will keep it 5 for now. And then, so to measure the frequency, what you have to do here is to go for the horizontal section, and then here let's say you change the horizontal time division here to 5 milliseconds. So in a single time division it measures 5 milliseconds, here 10 milliseconds, 15, 20. You know, for this is a sinusoidal signal, and 20 millisecond for a cycle time means 50 Hz frequency. 1 over 20 millisecond is 50 Hz. So you can have a clue of the frequency from this graph as well. And if you need to measure those things, you can select the cursors and you can drag the cursor here and there in this screen, and here you have the peak value as 20 and the minimum peak negative peak value as around -20, and then at each and every point you will have the time value. So here the time value will be 5 millisecond, and at the next peak point the time value will be 25 millisecond. Therefore the gap between these two peak points is 20 millisecond. Therefore you know the frequency is 1 divided by 20 millisecond, 50 hertz. So you can get a clue of the frequency from these cursors as well, and not only at the peak points but also at the points along this curve. You can find the voltage and the time values, and if you need to close the cursors you can go there and click. And then an important thing is, if you need to measure the DC voltage waveforms, especially the pulse signals including PWM waveforms, you need to go for this section and select the toggle button to the DC section here. And that's all about the usage of oscilloscopes in Proteus. Thank you.